Okay, welcome to Unit 1, Lesson 2, or 1.2, Lesson 1.2, Introducing Geometric Sequences. Okay, here are the first two terms of geometric sequence. So the first thing I'm going to do is I know that geometric sequence multiply and divide. So the first thing I'm going to do is I'm going to write multiply and divide. So every time you see the word geometric, write down multiply and divide. All right, 2, 4. How do I get from 2 to 4 by multiplying? Well, times 2. And then the instructions say, what are the next three terms? So I need three more terms. So 4 times 2 is 8, times 2 is 16, times 2 is 32. Okay, there's the next three terms. Okay, what is the growth factor of a geometric sequence? The growth factor only applies to geometric sequences, and geometric means multiply and divide. So how do you get from 1 to 1 to 1 to 1 by multiplying? So the growth factor is times 1. And 256 to 128 to 64. Well, I'm not sure about this one. I don't know. So what I'm going to do is take the number on the right and divide it by the number on the left. In my calculator, it's going to give me 0.5. I got the Calculate 84 app on my phone. I'm going to hit on the left side. You got to look up. There's a very top row, and then there's a gap. And then there's another set of buttons. And the third one down in that second set is math. Hit the math button, hit enter, then enter again, and that's going to change that to 1/2. 18 to 54. Again, I'm not sure. So what am I going to do? I'm going to do 54 divided by 18. That's going to give me 3. So I know I had to multiply times 3. If I do 18 times 3, I will get to 54. Okay, now let's look at D. D, the decimal point is moving left, so I know that I'm dividing by 10 or I'm multiplying by 1/10. Just because of the movement of the decimal. The decimal in E is moving to the right. That means I'm multiplying by 10. The decimal moves left, you divide by 10. If the decimal moves right, you're multiplying by 10. Okay, I didn't get a chance to do this one in class. So a person owes $1,000 on a credit card that charges an interest rate of 2% per month. Complete the table showing the credit card balance each month if they do not make any payments. Okay. This question is a little early for this lesson. We will see this again in Unit 4, but I'll give you the answer in case you're curious. So when you have $1,000 on your credit card, what you need is an exponential function. Now, geometric sequences are exponential functions. So an exponential function means y equals a, which is initial amount, times b, which is your growth factor, and where your variable is an exponent. That's why it's called an exponential function. Our initial amount is 1,000. We had to multiply that by 2%. 2% per cent literally means, per means divide, cent means 100. Comes out to 0.02. Now, this is growing, it's not decreasing. See, the interest rate is added to the balance. So because 1,000 is 100%, or 100 divided by 100 gives us 1, we add the increase in percentage, we get 1.02 to the x power. Now, if you hit on your calculator, if you hit y equals, is the button in top left corner, the far top left corner, you're going to put in y1, put 1,000, parenthesis, which is over the 8, 1.02, close the parenthesis over the 9, then hit the caret key, which is over the division symbol, and then hit xt theta n, which is next to the green button, and then that will put the function into the calculator, and then what you're going to do is hit second, the blue button, and hit graph. If you type all of these buttons in, you will get your table of values. And you'll see that the next number is 1061.21. You will not get the decimals, but I'm putting the decimals in here for you. And then the next number is 1082.43. And the next number is 1104.08. The next number is 1126.16. And the next number is 1148.66. I skipped this one in this unit because it's not that important, but we will visit this again in unit 4. Okay, now this problem is kind of important. So now there are two different things going on here. So we have to read this carefully. So in the first thing, we want to read the number of shaded triangles. So we are going to highlight the number of shaded triangles in red and the area of each shaded triangle in blue. So these are the colors we're going to be dealing with. So let's start with the red. All you got to do is count the triangles. So in 1, we have 1. In step 2, we have 3 shaded triangles. In step 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 shaded triangles. In step 4, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7. We have 27 triangles. So if we can predict our sequences like we did above, to go from 1 to 3 to 9 to 27 is multiplying by 3. So 27 times 3 is 81. 81 times 3 is 243. There you go. Okay, that was the easy part. Just count the number of triangles, predict your pattern, and then fill in the numbers. Okay, so that was the easy part. Now, for something a little bit more challenging. Okay, the black triangle is an actual triangle. The white triangle is what was cut out. That's why it says, and then removing the middle triangle in the second sentence. Or maybe that's in the first sentence. All right, so whatever. So basically, we cut this into 1, 2, 3, 4 different triangles. So that means we took the area and divided it by 4. So 256 divided by 4 is 64. Then we took each one of these triangles and divided it into 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 equal sections. And so we divided it, each triangle, each one of these triangles by 4 again, getting us down to 16. So the pattern is dividing by 4, and that gets us down to 4 to 1 and to 1/4. All right, if you can't see that, rewind this back and see if you can figure out the pattern. Okay, now I did this on the second slide. So graph the number of shaded triangles as a function of the step number, and then graph the area. So the step number was going up. Well, let me put that in red, I'm sorry. So without even a formal graph, the first graph is 1, then 3, then 9, then 27, then 81. So we can see that it's curved and it's going up. The second one started at 256, then it went down to 64, then it went to 16, and then it went to 4 to 1 to 1/4. And again, another curved graph. So one is increasing from left to right, one is decreasing from left to right. So if I had to draw some axes, I would make this my X, make this my Y. I made my Y first and my X. And then on the second one, I made my X and my Y and my Y and my X. Okay, X is always horizontal, Y is always vertical. All right. Okay, so practice problem number 5. Here's a rule to make a list number. Each number is 4 less than 3 times the previous number. So we're going to do 3, the previous number. I'm going to use n for number. You can use whatever variable you want, and then minus 4. Remember, less than means minus 4 after the variable. So 10 is our first number. Times 3 is 30, minus 4 is 26. Times 3 is 78, minus 4 is 74. See, I got a calculator, so don't think I'm doing these in my head because I already messed up twice. 74 times 3 is 222, minus 4 is 218. And then times 3 is 654, minus 4 gives us 650. Okay, start with 1. Times 3 is 3, minus 4 is negative 1. Times 3 minus 4 is negative 7. Times 3 is negative 21, minus 4 is negative 25. Times 3 is negative 75, minus 4 is negative 79. And code. All right, so build your list of numbers. So pick a number. I don't know, 2. 2 times 3 is 6, minus 4 is 2 again. Wow, look at that. 2 times 3 is 6, minus 4 is 2. Wow, this keeps coming out to 2. Well, sometimes it works like that with sequences. All right, our last problem. A sequence starts 1, negative 1. Give a rule the sequence could follow. So what if we what if we just kept multiplying? Our growth factor is now, it doesn't say this is geometric, so you could pick anything. You could do multiply by negative 1, and we would keep getting 1, negative 1, 1, negative 1. Now give a different rule. How do we get from 1 to negative 1? Well, we could subtract 2. What am I doing? Sorry about that. This is negative 1. Negative 1 minus 2 is negative 3. Minus 2 is negative 5. Minus 2 is negative 7. So if we subtracted 2, this is not a growth factor. This is something different we'll learn about in the next lesson. So thank you for watching this video. If you have any questions, rewind it back. If you still have any questions, come see me.